As Chris said, please feel free to throw in on the chat or whatever, however you want to do it. Questions that come up. Um, One thing he didn't mention, this is, if you need it, this is an approved course with AIA. It was registered, it's been approved. So if you need course credit, please let me know. There's my contact info. Obviously, NFCA knows how to get a hold of me. Otherwise, I'm gonna jump right in. The first couple slides, I'm just gonna blast by because they're kind of standard slides. If anybody wants a copy, and I know I got to send it to you guys at NFCA, they will have it. I don't mind sharing the slide deck, so please ask. Um, Course description, I won't go into that. Course objectives, we're going to cover each one of those either through direct talking about it or through your questions. Disclaimer, it just means that ISC Logic is a provider and the course content is ours, and we're the ones that's going to be responsible for it. So one of the things you don't like to do is like these, I call them framing questions, or ask yourself, um, you know, when and why did the flooring adhesives change from VOC based? If you've been in the industry a while, people say, "Oh, we used to have good glues, now we have bad glues." Well, we still have a lot of good glues, but they're just more particular than the glues we used to have. What a lot of people don't know is just how far back this issue goes. It actually goes back all the way to, well, even way before 1991, but that's really when it became a culminating. There was the carpet talks, it was called, between the EPA and the floor covering industry. And basically, and this is all in the public record, by the way, the EPA, because of concerns over VOCs and the built environment and indoor air quality degradation, was having these talks with the flooring industry. It's like, how can we lower the VOC emissions in the built environment? That culminated in this document right here in 1992, in which the flooring industry agreed to start testing their materials for VOC and to explore ways to reduce it. And that same year is when we had the green label adhesive program come out. And these were the low VOC adhesives. So really we can put our finger on as far back as 1992 when the adhesives changed, when a lot of the VOCs were pulled out and water was pulled in. Before I would leave this slide, I want to be very clear with VOC as opposed to the word solvent. A lot of people say, well, we used to have these solvent-based adhesives and we lost these solvents. Well, technically speaking, in chemistry, water is the universal solvent, because I guess more things actually dissolve in water than anything else, which I didn't know. I think it was pretty cool. But water is a solvent too. So to say we lost solvents is not technically correct. We changed the solvent, but we did lose is a significant number of the VOCs. So that's how far back this issue goes. Now, basically what happened in 1992, the adhesives changed pretty dramatically, the formulations. What didn't change was how we installed those glues. So there were still installers out there with sweat dripping down their nose. Okay, maybe it's not so much in Canada, but you think about Mississippi on the Gold Coast, or the Gulf Coast, where they're installing flooring and in August, sweat dripping down. It worked great with cut back and other kinds of adhesives. Doesn't work so well with a high water contact adhesive. They were still installing the same climate, high humidity, temperature, whatever, and really led to massive failures throughout the 90s. And so as the 90s closed, that's when F710. So when we think about moisture testing, most people don't even think about it now because it's everywhere. This is the document, and this is the year it became a requirement. F710 established the requirement for moisture testing, and I want to be clear on the word alkalinity testing, as far back as 1998. And so for moisture testing in 1998, 2170 RH probe did not exist. So this was the exact language from that 1998 document. And you can see shall not exceed 3 pounds, which is practically or almost nearly impossible to achieve, just because the dome itself and the moisture that can be sucked out of the dome itself. And so that test was there, but it also had the requirement, and this I want to be clear, alkalinity testing. And I think this is really leads to a lot of confusion of why people say pH and alkalinity as being the same thing. Well, as far back as 1998, if you read this right here, it says alkalinity testing, and then it says levels of pH shall not. So even our own ASTMs kind of confuse the terms, but I'll go through that in a little bit more. This was the test. This was the pH test. It was embedded in 19, as far as back at 898, and it was the pH paper. Drop of water, wait 60 seconds, test it with pH. And if you recall, or if you're familiar with the calcium chloride test, I think many, if not all, of the manufacturers of the calcium chloride test also include pH paper in that kit. That's not a coincidence, because in 1998, those were the two tests required. So a lot of manufacturers just package them together. But what I want to point out is that pH cannot be measured on a dry surface. So you can't take a pH strip and just touch it to the concrete surface and get a reading. You need a solution. So to even measure pH, you had to add water. You had to wait, and then you test the pH of the water. So you're not actually testing the pH of the surface of the concrete. You're actually testing the pH of the water that was placed on the concrete. A couple of things I want to point out too is that the standard says a clean concrete surface. A lot of people, because they were doing the 1869, which required abrading the surface of the concrete, would abrade the concrete and test where they abraded. That was never correct and never part of the standard. And that also gave a lot of high readings, because once you remove that carbonated layer, you expose the higher alkali material below, and it wasn't unusual to get automatic high readings. The other thing too is it had an admonition or a warning, readings in excess of 9. But there was no mention, what about less than 8? What if the number went down? I mean, if you're expecting the pH of concrete to be 8, 9, or 10, and you test that surface and it's a 7 or a 6, that should be cluing you that something's not right, because the pH of the surface of concrete should not be that low. Okay. Another question to ask yourself, are they the same? Based on what I've said so far, you should probably be cluing in. I'm guessing no. So first off, I want to just run through what pH is. What does it come from? It's actually, there you go right there, potens, and that's German for power, as in an exponent, like, three squared, two is the exponent. That's what the power is. And so we often refer to it as the power of hydrogen or the potential of hydrogen, but that's the derivation. It's expressed as a logarithmic scale. So if you go from a 7 to an 8, that's not a 1 increase, that's a 10. 7 to 9 is 100. 7 to a 10 is 1,000 increase in the pH reading. So that's how the scale works. Now, what the pH is determining is how acidic, that's the concentration of the hydrogen ions, or how basic or alkaline, not alkalinity, how alkaline the material is. So the lower the number, the more acidic; the higher number, the more basic or alkaline. Um, wet concrete is very alkaline, 12, 13. A lot of your underlayment material, thin set material, floor prep material, same thing, very high alkalinity, or high, there we go again, highly alkaline when they're in their wet state. So keep that in mind. You want to protect yourself when you're working with this material if it's wet. And this is the reason why I think that people confuse pH with alkalinity, because, well, first of all, F710 since 1998 actually had alkalinity than pH, but also the words alkaline and alkalinity are very, very close, and so they equate the two, but they do mean something differently. So alkalinity, and I think I have a good example to bring it home here. Alkalinity is a measurement of all the alkaline substances in that solution. And so it's not so much the actual measurement of the pH, but it's going back and figuring out how much alkaline solids are dissolved in that solution. And these materials are able to resist a change in pH, meaning if you have an alkaline material, let's say bleach, let's say a solution of sodium hydroxide or whatever, it those hydroxides, those material in that solution, as you add acid, it resists it dropping. So that's really what alkalinity means. And so total alkalinity, and it's usually this discussion is usually with water purification plants, pools, keeping it balanced and things like that. It's your bicarbonate, your carbonates like calcium carbonate, your hydroxide. Think about concrete, potassium hydroxide, sodium hydroxide, calcium hydroxide. Those are the things in solution that resist the pH dropping. It actually helps to absorb or buffer against added acids. Um, and so that's really what alkalinity is. It is a measurement of this concentration. So here's an example I wanted to give. Think about an antacid. Okay, think about a Rolaids or a Tums or an Alka-Seltzer. If you look at their ingredients, they're a carbonate, they're a sodium bicarbonate, they're a hydroxide. There's even one product called Bufferin, and it's a calcium carbonate and aspirin, so it's a buffer in an aspirin, so bufferin. So that's what
Hey,
alkalinity means.
Dean, let
Yep.
me just, so if I've got a stomach ache, instead of taking Tums, could I drink some lemon juice, which I believe is alkaline?
You're going the wrong direction. Lemon juice is an acid.
Okay.
Yeah, lemon juice. Now, people don't know this, so is milk. Milk's acidic.
Hmm. Okay, so if
Yeah.
I drank an alkaline solution, I thought lemon juice was alkaline, but there.
No, no, no. Most now they do have the alkaline waters out now. They'll have the high pH waters. That might that would give you more relief than Coke is acidic. Almost every single
Hop,
soft drink is acidic.
sugar.
People don't realize this. Milk is acidic. Any kind of citrus is acidic. And in fact, um, one of the methods, the old methods that people would use if they were concerned about pH, they would do a citric cleaner on top of the concrete surface because the citric cleaner contains citric acid, and that the residual pH on the surface of the concrete, the residual alkalis would help buffer, and they would neutralize one another, and it would actually lower or help. It would help neutralize those pH or those hydroxides or whatever on the surface of the concrete. And when they tested it again, it was one way to neutralize or lower the surface of the pH concrete by adding an acid or an acid wash. They didn't call it an acid wash; they called it a citric cleaner. But yeah, lemon juice, orange juice, that's all acidic. So don't want to go that direction. Again, milk, people think, oh, milk is thick and creamy. It's going to help coat my stomach. Actually, milk too is acidic. So you want to be careful there as well. Anyway, good question. Excellent question. So long story short, alkalinity is just a measurement of a material's ability to resist having its pH lowered. And the stronger or the more alkalinity a solution has, the more acid you have to add to start lowering that pH. Um, Titration, I won't get into that, but that's how you measure it. You take a known acid and an unknown solution that have a higher pH, and you start adding the acid a drop at a time until you see all of a sudden the pH will change rapidly. And then you can go back and calculate, oh, there's this much hydroxide or bicarbonate or whatever, and it's actually measured in you can see milligrams per liter of calcium carbonate or whatever. So pH is a logarithmic scale of acidity or how basic. Alkalinity is actually measuring how much substance is in the material. So definitely not the same thing. Related, but not the same thing. Okay. So what should the pH of the concrete be? You're out there, you're doing work. What should the pH be? And there's many sources out there. It really should fall on the low range of an 8 to about a 10. Those ranges should not be a concern whatsoever. But what I want to show you real quick, and I'm going to come back to this, where those numbers come from, and also, how it can actually skew you depending on what you use. Grace Labs, 2009, Peter Craig in the States was involved with this. And you can see how the results they got differ dramatically across the various pH papers. You got 4 papers there. One, you have an 11 on paper B, and the same sample tested at 8.5 with paper D. I mean, remember, this is a logarithmic scale. That's a 250 times power difference. Look at paper C under 300 seconds, 8.5 to 12. But if you look at the meter, the flat electrode meter, they were consistent almost invariably across it. Now they only tested 1 meter, but one of the concerns is just be careful about the paper. But by and large, the pH of the concrete should be in the 8 to 10 range.
So now the
Now,
ASTM that has just been published and updated allows for both methods of testing, right?
correct. And I'm gonna touch on that. And it's a different kind of method. And I'm glad you brought that up. But yes, And I even mentioned that it mentions both methods with the preference given to the flat electrode, because you can calibrate the flat electrometer. I mean, so you can't calibrate the paper. And if you don't know which paper you have and where it compares to other things, you could be you could be way off. I mean, just look at the scales right here. It's the same sample tested, and you can see again paper C, paper D in the 60-second column. And the reason why that's yellow or orange is because that's the time limit. You can see there's a pretty dramatic difference. Um, and if you actually compare paper D to the meter, you're a full 300 power off. So you could be going from paper D says it's pass, let's put it down, where the meter says danger, don't put it down.
So here maybe is
So
a stupid question. Is there only one type of distilled water?
yeah, distilled water is actually a defined, and so is deionized water. There's a definition. No, that's not true. There are actually different levels of distilled water. Um, um, but for the purpose of doing these tests, it all is going to qualify. Um,
Because,
it
because
gets really, really nitnoid as far as what makes it a
it,
higher level of distilled water. But
essentially, if it is distilled, it is pure. All the contaminants are removed.
correct. But I want to touch on the water, because the water itself can be one of the biggest contaminants, not
Yeah,
because it's induced, but because how exposed water reacts with the atmosphere. It can actually carbonate. Water has a tendency to absorb carbon dioxide, and even as little as 2 hours, and as it absorbs carbon dioxide, it actually acidifies, and water can actually just exposed to the atmosphere can go down to a pH of about 5.6.
mm,
So one of the things I thought was a significant glaring error in all the pH evaluations was people automatically assumed that the water was 7.0, but none of the evaluations required the major part of the test, the water, to be evaluated before you put it on the concrete.
mm.
So if you're starting at a 7.0 water and you got an 8, that's only a power of 10, or a 9, that's a power of 200. But if your water is acidified and you don't know it, and your water is really a 5.6, and you tested 10, you're like, oh, I'm good to go. Well, that's a 4.5 power increase. And I would argue now you're outside the range of what you thought you were. Everybody always assumed that the water you're testing with is a 7 pH and you're going from there. But the water itself can actually acidify if it's been left open to the environment.
Strong
Um,
reason to go electronic, I'd say.
yeah, quick test the water, put it on there, test it again, and then subtract the two, and that'll give you an idea. It's like, hey, this has been an increase of 3 or 2 or 1, as opposed to a straight pH of 9, and I'm good or whatever. So here's a really good article, and you think about the time frames. 2003. So this is 5 years after F710. And one of the things is, they talk about how the test method went. They spread some glues down, left 15 to 30 minutes. Not so unlike some adhesives today. This is just how the test was set up. And what one of the things they showed is just how much water or solvent some of these adhesives imparted to the project. So you can see 6 water-based adhesives, separate adhesives, 1 solvent-based, and the average. And you see the open time. The one is a very short open time, number one, but the rest of them, average 10.6. Then look at the middle column. What they did was they spread it down, what the open time, and they weighed the sample very, very carefully. And at the end of the open time, they weighed it again. And so that is the calculation of how much liquid was lost during that open time. Lost, it could have been more evaporated, some absorbed, but that's what they measured. And so what they were trying to determine was just how much water or solvent would be available to be absorbed by the concrete. And that's your far right-hand column. Remember, the limit all the way through this time period for concrete was 3 pounds of moisture. So they actually equated this to pounds of moisture per 1,000 square feet, and the average was 130 pounds. The limit for concrete was 3 pounds. So the water itself, on average, or in the available free water or solvent in these adhesives, were contributing to upwards of 130 pounds per 1,000 square feet. So think about that. You test a concrete slab, let's say it did pass the 3 pounds. You spread this liquid on there. To automatically assume all that liquid went to the environment is a false assumption, because you have some potentially to be absorbed.
So for a
Radically,
so,
go
so
ahead.
for a flooring product like linoleum, which is, you know, sort of a wood-based makeup, would have a significant problem with that water-based adhesive putting out that much moisture.
Well, that's kind of what I wanted to touch on. We were talking earlier, Chris, is that the automatically assumption that the water that caused an issue came from the concrete. The glues today have evolved substantially. Um, but if you go back in time, go back to 92, 93, um, this report wasn't even done. This study wasn't even done till 10 years after the glues changed. And so there was a lot of information that came out later. Think about a resilient sheet that's basically impermeable. If the right open time wasn't allowed and just the surface of the adhesive skimmed off, but the body still had a lot of excess moisture and it's a non-absorptive surface, and then you lay in a resilient sheet that has where's the excess water going to go?
Yeah, just turns into emulsion like paint.
And it's in contact with a high alkaline material. So the residual alkalis in the concrete start going into solution. And now the pH of that adhesive starts going up to a point to where now the adhesive itself starts breaking down because the more and more alkalis it's exposed to. So then what really induced the failure? So this is one of those things that kind of causes a conundrum, but just some data a lot of people are not aware of. And so what they determined is that the adhesive itself likely adds a significant amount of water to the surface of the concrete post moisture testing. The impact on that concrete is never determined because there's no post adhesive spread moisture test to verify the concrete is still within the ranges. So keep that in mind. And what they found is almost invariably after they installed and they removed the flooring, that it was almost a fait accompli that it would be in excess of the 3 to 5 pounds of moisture. They also tested um, the the adhesive. They noticed that within just a few minutes after spreading the adhesive, the surface pH went from 9 to 11.5. And the only source of liquid that allowed those residual hydroxides or carbonates to go into solution came from the adhesive itself. There was no other source of moisture. This was not days and weeks and whatever. This was nearly instantaneously. So again, if that adhesive broke down, what was the cause that created it? And this is going to build into this right here. Syntef, you may not be aware of. Uh, you can read what it is right there. They put out an article, and this is a very, very good one. If you're interested in this particular topic, this is a really, really good resource to go through. A lot of great information, and that's the title. If somebody wants it, I can provide it as well. I can send it to you. And what they notice is obviously concrete obviously contains a lot of hydroxides and alkalis, all those things that raise the pH. And they say typically around 13. I mean, fresh concrete is very, very caustic. It will eat a hole in your skin. But again, just like F710, it does say that the surface of the concrete is going to carbonate. It's going to those hydroxides will react with the calcium or the carbon dioxide, carbonate, and it'll lower that surface of the concrete to make it not detrimental to adhesives. And F710 references 8 to 10, but they're very similar. Um, so one of the things to be aware of, if if the material you're installing has a max pH limit of 8 or 9, it should cause you pause, because all the literature expects average concrete to be 8 to 10. So if a product is listed like max pH of 8, you really should be questioning it if it even should be used in contact with any cementitious material. And that goes for concrete, that goes for prep material, underlayment, things like that. So that's just one of the things. And I have actually seen glues where the max pH is 8. And I've gone back to the contractor. I'm like, that's probably not even gonna be in the range of the normal concrete. So it's just really the glue you plan on using. So just keep that in mind. Um, and remember, even though the average pH of the concrete, they noticed that the pH rose from 9 to 11.5, understanding, of course, maybe they were using paper D or whatever that was skewed, but it can make a change pretty quickly. Um, so what they noticed that what actually causes failures. Now let's get back into flooring failures, why you guys need to be concerned. So what is happening when this pH level rises is called um, uh, alkaline or basic hydrolysis. And that is the adhesive or the flooring backing being put into contact with these hydroxide ions, the OH, in the solution and breaking down. So to say pH is not important skips what actually is the chemical reaction that's causing that material to go back to a goo or the backing to degrade. It's a high alkaline environment based on a solution. Regardless of what caused the water to happen or the liquid to happen or the alkalis to go into solution, whether it's moisture vapor emission, condensing, or it's the adhesive itself contributing the moisture. Once that solution goes to a certain level of uh, basic pH, 11, 12, there's a good chance it's going to start attacking the chemical makeup of that adhesive or product. And that's really what leads to the breakdown and even VOC off gassing, because it gets into more chemistry, but these hydroxide ions attack the adhesive or the backing and it turns it to goo, but it also releases alcohol, which causes odor in the VOCs. And so you have a downward spiral, but it's not the alkalinity, it's actually the elevated pH of the solution. Now, what they also noticed was just how much liquid is in some of these water-based adhesives, 25 to 30%. Now, I know a lot of our adhesives today are much lower. So again, I'm giving you like an historical perspective of where pH testing came from. So a lot of these failures could be pointed out to the misapplication of an adhesive that just had a lot of water that went on a non-porous substrate, wasn't allowed to evaporate, and then cover with a floor covering too fast. If it didn't have anywhere to go, it's going to cause those alkalis that are dry and silent and behaving themselves in the concrete, possibly to go into solution and then cause mischief. So then you cover with flooring, and then basically the adhesive itself is now the culprit that's attacking itself. So anyway, there we go. And Syntef goes through into wet and dry bonding. And this, I only go through this right here, not to tell you guys how to install flooring, but to show you this how far back the idea of how important the substrate surface absorptivity is. Even as far back as this, so now we're at 17 years ago, they talk about the substrate and what kind of bonding technique should be used. If it's a wet set adhesive, where is that additional liquid going? You only allow it to offgate so much, or you lay the flooring into the wet adhesive. Well, it'll either cure on its own or something that's going to absorb in. Is that adhesive's pH tolerance high enough to survive in that environment? Some are dry. Those are good for, they're going to thinly applied. They're going to off gas quickly, dry to the touch. Your pressure release adhesives. Those are going to be like those kind of adhesives. The ones that are tack off quickly, put on a paint roller. Those are good for that. But one of the things it really points out to is these substrates. Be very careful then. How you apply your glue does have an effect on what kind of substrate. And this was pointed out always far back as 2007. So the whole thing about absorptivity, they said non-absorbing. In the US, the words porous and non-porous were used, which were actually never correct. Porous just means having pores. Non-absorbing means doesn't soak in. So when we get to the test method or the practice or guide for F7, F3191, it'll say absorbing, non-absorbing, then in parentheses, porous, non-porous. It's just to be technically correct. So again, as I round up with 2007, they actually did plenty of examinations on failed floors, and they actually found out that quite a few of the damaged floors were not the result of concrete moisture. They are actually the result of the misapplication of adhesive on a non-absorbent substrate. That water had no place to go. The alkalis raised up, and then it started attacking itself. So
Would absorbent or non-absorbent also be affected by the viscosity of the adhesive being applied? I mean, if it's super thick, an absorbent surface would then become non-absorbent.
correct. So think about your epoxy or urethane adhesives. Well, urethane's moisture cured, but think about some of those glues. They're not gonna soak in. I'm talking about, like the ones that are 25, 30% water. I mean, they're going to be loosey goosey. They're going to be able to soak in. Since the 90s and early 2000s, the adhesive chemistry has changed substantially, where I think there's a more solid content. There's a better idea of what is a truly acceptable level of an excess liquid. And even on the pure wet set, we reviewed adhesives. I see them less and less. And what I mainly see now, I see very few adhesives really that are only for porous substrates. If anything, a lot of the adhesives out there are suitable for both porous or absorptive or non-absorptive. They'll just change the trowel size. So basically, you're using half or less than half of the amount of adhesive for the non-absorptive surface than you would for the absorptive surface. Um, but again, the idea that this liquid is soaking into the concrete to like bind with the concrete, that's not really how it works. It's supposed to cure and dry, and that's going to actually help set the material in. Um, but even as far back as 2007, you see how we're coming back again to the pH. They were recommending high alkali resistant adhesives all the way back then, specifically on concrete, because of their research. So this is not new information, which is what many of the adhesives today. And in fact, a lot of the manufacturers on the F710, F6 committee, a lot of the adhesive manufacturers, they're like, I don't care about pH. So a lot of your glues out there that you're going to come in contact today are not affected. They'll have pH limit of 14. They're just saying, hey, whatever, don't care. So we've evolved, but when we go back to failure analysis of things of what occurred, we can't go back to history and say, okay, hey, this floor didn't actually cause the concrete moisture actually didn't cause this failure. It was actually, a lot of water in the glue on a non-porous, a non-absorbent substrate that caused the damage. But just keep in mind this adhesive selection and substrate absorptivity are critical, and it leads us to 3191. And I don't want to try to be too gloom and doom here, but at point of installation, this is one of the most important, quickest, and easiest determinations that an installer can do. And as I said, even though it says you'll see absorption because it's the right word, but we kept porosity in there because so much of the flooring manufacturers' literature said suitable for porous or non-porous, or open time and spread rate is dependent on site conditions and substrate porosity.
Would you say a good absorption test is basically a bond pull test?
Well, the absorption test, that's a separate test. This right here, the water drop test is your absorption test.
Yeah, well, the reason I say it is because you can do the droplet test on regular concrete, and maybe the timing is healthy and the time it takes that droplet to disappear. But then you come along with an adhesive that doesn't treat or react the same way, and you essentially it turns the surface into a non-absorbent. At that point, a bond test is probably what is going to tell you that you've got healthy absorbency, not the droplet test.
Or you have the right product for this the substrate conditions. I'm a big fan of bond test. I think any installer that doesn't do them is missing an opportunity. Huge fan. And basically the standard is do whatever test the manufacturer says. In the absence of that, you got F3311, which is, great ASTM, put a sample down, minimum 72 hours, go back, pull. Some of them are qualitative, fantastic tests. Don't get me wrong.
So simple. Why
Um,
wouldn't you do them? Yeah.
ye- yeah. And the thing with the porosity test, it's so quick and easy. I mean, you could be doing, you know, hundreds and hundreds and hundreds of yards of resilient, and you could have somebody just going in front of the next drop, um, doing a water drop, every 20 feet, just to, because it can be variable, just to make sure and to test. And one thing people don't understand about is this test is not for concrete. This test is for all substrates to receive resilient flooring. Think about a well-bonded course of resilient floor. That's a suitable substrate for another course of resilient flooring. Well, that surface of that resilient flooring is going to be non-absorptive. So the idea that substrate surface absorptivity, porosity, is only a concrete issue, no, it is whatever your adhesive is touching. I know, I know some installers and some big installation groups in the States that their standard practice is they include in their bid, they skim coat the entire project. Well, guess what? That's not your new substrate. You still got to do the porosity test. Because the idea is, well, I skimmed it, it's porous. Maybe, maybe not. Do the water drop test. It's quick. And we did this. We did it on a project in Lakeland in Central Florida. They're like, oh, we skimmed it, it's porous. Did you do the water drop test? 12 people standing around, architect, owner's rep, GC, flooring contractors did a water drop test. Just sat there. I go, non-absorptive surface, using the wrong trowel size. It makes that much of a difference. I mean, literally, if you look at some of these glues, you could go from a spread rate of 350 per square foot to 150 to 200 per square foot for a porous surface. So if you're using the wrong size trowel on a non-porous, you're using basically twice as much glue. And then you lay your floor in, you're going to have indentation, you're going to have oozing, you're going to have a lot of problems. So as far back as 2016, it was all substrates. It got bumped up with an F710 in 2021 as required there. And basically, long story short, it says do what the manufacturer tell you to do for porosity. Last I checked, Ultro says assume all concrete's non-porous. Nora, I think, said wait 2 minutes or 5 minutes, and I think maybe Forbo.
I think Nora were 5.
Maybe Nora was 5 and Forbo was 2. But other than that, there was nobody defined what it was. So basically, the standard says do what the manufacturer tells you to do. If that manufacturer does not publish a way to do it this way. That's what the standard is. So, and again, guys, ladies, this is a drop of water in 60 seconds. This could really make a difference on your prep, on your adhesive selection, on your the trowel. I mean, it really has a big deal.
It can cut both ways. It can be too absorbent and suck all that
Correct.
moisture out.
Correct. Yeah, I got a picture coming up here. This is just some paper I'll go through here. But remember, it doesn't matter what products is. It just goes to show you why, because there's plenty of literature going back across iCry, manufacturers, everything, that absorptivity is a key factor in a successful installation. So if you're not checking it, you are skipping over a main point of how these glues, primers work. You're missing something. So just Keep in mind, another thing I want to point out is just because a surface is non-porous on a concrete does not mean that surface is contaminated. I've heard a lot of people say, "Oh, it means there's a curing compound. We got to trip it off." No, it probably means the concrete was troweled. And in fact, most concrete will test as non-porous because of how it's finished. Those machines out there, those writing machines, put a lot of weight and pressure. And the if you look at ACI, the purpose of troweling is to provide a smooth, dense, hard surface, which means non-absorptive. So we talked about you talked about the document that got accepted, Chris, when we first started before we started the meeting. Um, One of the things people bidding in the flooring contracting world, they should go into every single project that's concrete, assuming non-porous surface and bid accordingly. That doesn't mean you have to go bead blast the entire surface and self-level. It might just mean you got to pick a different glue. And in most cases, that's what it means. Pick a different glue or use a different trowel.
Construction
So,
plan to just broom finish and then leave it.
well, that's actually the European standard, broom finished, and they self-level everything. But uh, that's a long way to go before I think North America is going to accept that. But so here's what the ASTM says. It just may require adjustment to the surface prep or product selection. That's me all required. No need to raise it to a 5 alarm fire. It's like, oh, it's not porous. Okay, we need to switch to that glue because it's good for both, and or we're already using that glue. We got to use the small trowel instead of the big trowel. I mean, literally, it could be that much of an adjustment. There's no reason to burn the project down saying, "Oh my God, it's non-porous." We got to do all this stuff. Most cases, no, you don't. Even with Ardex, they've got primers, and they're I don't mean to call out a particular product, but like their feather finish can go on a non-porous substrate. So, I
So,
mean,
but that's interesting that so non-porous as a term is
is the
states.
wrong term, but anyway, yeah.
Yeah, because I mean, in my mind, you're talking about metal for a potentially for a substrate.
Think about non-porous. Think about porous. All means is that having pores. That's what it means. Like
Yeah.
gas bubbles, like
Oh,
glass. Glass, glass has porosity. They're very tiny, but it's not absorptive. So absorptive is the real word you want to focus on.
yeah.
Does that liquid soak in? That's not the word. And again,
Absorbent, not non-absorptive
correct.
is
That
absolute.
is that is the correct term. But the reason why this ASTM keeps bringing in, always non-porous in here like this is because so much flooring literature says suitable for porous or non-porous. Those words were so entrenched in so much literature, we brought it over to the standard just to keep it on there. The standard is about as easy as possible. A drop of water, wait 60 seconds. Properly prepared concrete substrate. What that means, and this is defined with an ASTM, properly prepared for whatever you're installing. So if you're installing a resinous flooring that requires an I-cry of profile of 3, well, bead blast the crap out of it, and there you go. If you're doing resilient sheet and you're putting adhesive down with a paint roller, and that adhesive is good for a non-absorptive surface, clean it. Don't abrade it. Don't just whatever prep is necessary for what you're installing. That's what you do the absorptive test on. Now, that includes prep material. If you're going to skim the entire thing, do the test, follow the instructions for the skim coat material. Then you got to test again. You can't assume any layer you put on there, you got to keep testing. Usually the biggest one would be a skim coat material. Don't assume that skim coat is going to be absorptive. I've seen plenty of them that are not. Doesn't make they're bad. Just don't assume. It's a quick test. It's the quickest test you can do. Here's the pictures right from the ASTM. A lot of people go, "Oh my God, the one on the left, there must be a curing compound. There must be wax. Nope, that's just a trial surface of the concrete. That's all that is." And the one on the left, it looks almost like a CMU block, but it actually almost looks like a sandy surface. But you can see how the water drop is really pulled out. May not have soaked in actually. That might be like a CSP of 1 or 2, and the surface tension actually pulled the water drop, spread it out. Um, but that's what you could see. It's very unlikely that that water drop is just going to go straight in. That would be kind of freaky. Most likely you're going to see it spread out like that. So anyway, there's an example. Very, very quickly, very, very quick test. Please don't skip this test. Now for pH, this one right here, the evolution, in 2013, the committee that talked about F6 committee talked about pulling it out. First and foremost, ASTM rules don't allow a test within a practice, and I'll get into what those mean in a second. So how to do a test method should never have been in F710 because it's an ASTM practice. Saying a test is necessary is not the same thing, and then referring to a test as actually writing the test itself. So the only place the test existed was in F710, which was procedurally wrong. In 2021, pH test was removed from F710. There was language put into the appendix, but from 2021 to 2023, there was no published pH standard. Didn't exist. This new standard wasn't published until 2023 with a small revision in 2024. It's a guide. Within ASTM world, you have practices, specifications, test methods, terminology, guides. They're all ASTM standards, but they all mean something different. So a guide is a compendium. It's like, hey, here's a body of literature to help you better understand the situation. It may recommend some things. In this case, it recommends 2 different ways that you can evaluate. This one actually as a comparative assessment, but it's an awareness. It's not mandatory. It's just gives you more information. As example, which you may not realize, 2659, measurement of moisture by the electronic meter, like say Tramex, that is still a guide. It's not a test method. I disagree with it, but I think it should be a test method, but that's a guide. A practice, this is F710. It's a set of instructions to perform. Okay. But you can see very, very clearly it says that does not produce a test result. That's why pH should have never been an F710. But F710 in the flooring world is the granddaddy practice. All right. That's what a practice is.
Every floor cover's best friend in the world of ASTM 710.
Correct. And that's an ASTM. It's ASTM F710 practice for preparing concrete slab to receive resilient flooring. You can almost forget the resilient flooring because it really applies to, heck, it applies to sticking anything in concrete. So
if you're a floor cover or a builder on this call, go to astm.org, plug in ASTM F710, download it for $50 US or whatever. It's such good information.
yeah, it's a good one. It still needs to be updated. Dew point's in there now. Porosity testing's in there now. pH has been moved out. So we keep evolving it.
You're going to be
As an example,
you're going to be tweaking it with the FFFL content?
yep. Probably not going to make it in May, but almost surely by the end of this year. Yep. Yes, sir. Yep. Moving forward. And then you have test methods. These are your F710. These are your 2170, 1869. A procedure that gives you a result that's been reviewed, precision and bias. So that's what I mean by this as being a guide. This is not mandatory language, but it's a way to do it. One thing about this standard, if you read it, it is not a direct evaluation of the substrate surface pH. It's actually it's a comparative analysis of the reagent water and then the reagent water once it's been put on the concrete. In other words, you take a clean glass dish and you test the water itself first. If you're calling before about the carbonization and the potential acidification of water, if you're going to have a valid test, one of the things you've got to try to do is remove all the potential contaminants or potential contaminants. Well, if your pH, if you're doing an electric meter and the pH of your water is 6.5, it ain't 7.0. I mean, there's a difference, and you should note that. Because what I think is more important is what you really should be concerned about if you're going to go down a pH evaluation is, did that reagent water, distilled or deionized, change from the glass dish after it's been on the concrete for 60 seconds? That's what you're looking for. Did it change, which it should? It should go up. How much it changed, and it sure as heck should not have gone down. Just to assume that you're starting off 7.0 is actually is wrong. As far as I know, no flooring manufacturers adopted this approach, but it's just something to keep in mind. So the idea with pH is this is a way to do it, but still deference is given to the flooring manufacturer to say if they want it done, how they want it done, or the project documents. And again, the reason why, again, is why it was written this way is because of the reagent water, and it's actually put into the standard in paragraph 7.5. It goes into detail as to why this evaluation is not just water on the concrete and test. It's water in a clean glass dish, test the water, then take that water, put it on the surface of concrete, wait 60 seconds, and then test the water again. Look for the change. And that change can actually help you understand better, I think, what goes on. And then this is acceptance criteria. It explains it very, very clearly. Again, first of all, do what the manufacturer tells you. All right. Do what the manufacturer tells you to do. If they don't tell you, you could still do it. You can still do it on your own, but do what they tell you to do. In the absence, if it's still required by the project documents, like say, hey, you're installing product A, but your project documents say conduct pH testing. You go to product A, they don't tell you to do it. Here's a way you can do it.
But then I
Okay.
got the manufacturer telling me you got to confirm a pH of somewhere between 7 and 9. And I'm registering 11. How do I get it down in short order?
Remember I said about citric acid surface cleaner?
Yeah, like muriatic. Maybe speak a
Uh,
little bit about muriatic acid. Is that a good
yeah.
option?
Oh, well, muriatic acid, that's a pull acid, but what I said about the citric acid, because that's a cleaner. Any acid is going to knock down your surface. If you got a high pH, and my business partner, he'd probably be mad at me saying this. He goes, that was a common thing they used to do. They get high pH and they would come in and clean it with a citric acid and they would knock it right down. They would knock it right down.
Would
I mean, if
you?
you got a pH of 11, what I would make sure, first of all, be where are you using paper or the meter? I would always recommend the meter because it's defensible. Because then you can say, "Hey, this meter's calibrated, and um, this is the result I got." Um, but in reality, the second thing I would do if I had a pH of 11, if the adhesive only had a limit of 9 or 10, one of the things I would consider first is to see if you can go to a more alkaline resistant adhesive. So no change may not be required. I'm always leery of adding an acid because remember the absorptivity thing.
Yeah.
Um, and if you look at F710, it tells you to be wary. Basically, do not use um, liquids to clean, adhesive residue because the concern is going to soak in and then come back up. Well, your acid could do the same thing. It's a liquid, so if you're not careful with trying the acid approach, some of that's going to soak in the concrete. And
Yeah.
then now you put new glue down. If you got any kind of moisture vapor emission and that now you have acid coming up, touching your glue, you don't have a pH now of 11 going on. You may have a pH of 4 going on. So
Yeah.
I'm always leery about I would also recommend instead of an acid, again, I don't mean to give a shout out to any particular company, but there's companies out there that have some really great materials that can provide a separation layer. Like for instance, I know Taylor has one. Uh, Pretty sure there's a number of out there that if you've got some dodgy conditions, I would rather see somebody put a material some of it's like very thin applied to encapsulate. That's the word I was looking for. Encapsulate, and then bond your glue on top of that. That's what I would do,
Yeah.
as opposed to doing an acid. I'd be very, very careful.
Seems like a real
Um,
roll of the dice acid. And even if you do get the pH down, would you at some level expect it to come back up later on once the acid's burnt off or disappeared?
I Again, it's about how much you put down. If somebody's going out there like, some kind of crazy gremlin and splashing it down by the, friggin', kiloliter, yeah, I would expect it to, but if somebody's like misting it on and then, wiping it off, most likely not. But that's a that's a fine line about, how it's done.
Highly unpredictable. Yeah. Yeah, exactly.
Well, it goes down to the least common denominator. Were you there watching the person do it? I mean, whereas if you encapsulate it, that's pretty visible and you're good to go because then that manufacturer has the encapsulation. They're like, yeah, we're not concerned about that pH. Put this down and move on with whatever adhesive you got. We don't care.
Do it
That's
once,
what
do
I
it
would
right.
that's
Agreed.
what I would
Yeah.
that's what I would do. And so here I put the comparative analysis and I said, so let's say your pH of your water is 6. Okay, it's acidified. I can still use it, no big deal. Then I put it on and it goes up to 9. Okay, that's a raise of 3, so that's like 7 to 10. That's kind of what I should expect for concrete. But if it goes down, then I'd be like, wait, something's not right. If I test the water in the clean dish and it's 6, and then I put it on the concrete and I test again, it's 5. That's what I mean about this comparative difference. Otherwise, how do you know which way you're going? Um, but you should expect it to be different than inside the glass. You should absolutely, and how you interpret it. Again, it all depends on what the manufacturer says. But so do what they say, interpret that we do, and then lastly, for this right here, there's two methods mentioned. There's the flat surface meter that we talked about before, and there's the pH test paper. Um, Tons of compelling evidence. Mapei did a great one. Bruno Boulanger did a great, so shout out to Mapei, did a great presentation at F6 committee on just the vagaries of the pH paper. I know Mapei is hardwired in support of the electric meter. You can calibrate them. You can actually send them off to get repaired. And as you saw from those results from '09 and the Gray study, the 4 papers, you could have a big disparity across the pH test paper. Um, Not saying don't use them, just saying that they are out there. That is a concern, and it could give you extreme variability, like you saw paper D as compared to paper B. B was like 11, and paper D was at 8.5. So just just be aware. And then lastly, pH paper, I believe direct sunlight, as it gets old, it can also degrade. So just because you've had it for 5 years, um, be sure you understand that product. I don't want to bash it at all. They're out there. They've been used for decades. Just to be aware that there probably is a better way to do it with the meter. Last slide. There is no ASTM that makes pH evaluation a requirement. Zero, none. Um, if it's not in the manufacturer's instructions or your project documents, you're not required to do it. If it's not in the manufacturer's instructions or your project contract documents, you're not required to do it. I didn't say you couldn't do it just on your own, just so you have an idea and you can record it. You saw how fast this test is. Test the water, test the surface, 2 minutes. But I'm just trying to be very clear. There currently is no document that requires it from ASTM. So to be clear, I'm not saying it's not required. I'm saying there's no document from ASTM that makes it a requirement. F710 makes substrate absorption requirement. ASTM F710 makes dew point evaluation requirement. F710 makes moisture testing a requirement. There is no corresponding requirement for pH. And lastly, the way you do this test is on the same way you're going to prepare the concrete. No, you don't get out there and mechanically prep, grind, go crazy, and then test. That's going to give you automatically false high reading. However, the material says to prep, that's what you do to do this test. So actually that ends it. Chris. I know a lot of information, but let me open up to questions real quick, and please let people have at me.
Well, I'll kick it off with Evan. Thank you, Dean. A deep dive, as I warned everybody. It is a tough subject to get hold of, the pH especially. But it's good to record this stuff because we can go back and watch it at our leisure and repeat until we finally do get it. And we also have your contact number, so expect your phone to ring off the
And
hook.
you can have these, and I remember I got to send this to you and Lee. I got to send you guys the slide deck too.
Very cool. I got a question from Clayton. Does ASTM F3191 mean start to absorb or completely absorb relative to the 60 seconds?
Oh, it's completely.
So it's got to be gone in 60 seconds, not start to absorb at the
Yeah,
beginning.
gone in 60 seconds. Wasn't that a movie? Yeah.
All right.
But again, like I was talking to Chris about, um, check with your manufacturer first. All if you're doing ultra, they just say off the bat, all concrete's non-absorptive, non-porous. Nor I think it's 5 minutes, and I think Forbo might be 2 minutes, but other than that, it's the 60 seconds. And you're going to tell pretty quickly if it's starting to go in or if it's still sitting there. You're going to tell pretty quickly. I stood there and watched a drop of water for 15 minutes and it sat there. I mean, so yeah, I'm just saying it's like people are like going, well, this is weird. It's like trials concrete. It's not going to soak in. It's
Yeah,
evaporating now. It's not going in. It's evaporating. So
yeah, exactly. And add fly ash and over burnishing. It just you can have it for half an hour sitting there doing nothing.
correct.
Clayton again. Wouldn't a dew point issue also affect the amount of water that gets deposited on the floor just prior and during adhesive application?
Yes, sir, 100%. And I'm the person that actually pressed for and was successful in getting dew point evaluation added to F710.
Would the
Correct.
would the temperature of the adhesive affect absorbency?
Um, I think it's just water content because you wouldn't be letting it cold. It would still be liquid. It might be a little more viscous when it's colder. But then again, as long as you're in the operating range of the temperature of the products, remember most adhesives are the ambient's got to be like um crap, I'm gonna screw this up. Um Pretty warm, like 60 to, and the glue is supposed to be that way, same way too. Yeah, our MBRH is 35 to 55. Glues are like 65 to 85.
Yeah, Celsius would
So
be 16 to 28, something like that, 29.
yeah, so in those ranges, no, no.
Yeah.
And by the same token, if the ambient temperature is really cold, which shouldn't be installing, that would affect. So great question, but I guess I would turn it around as long as it's in the box, 35 to 55, 80 ambient, and then whatever Chris said Celsius for the temperature, then no, those temperatures will not affect the absorptivity or the ability of that material to be absorbed into a substrate.
Very good. A comment about the skim coat over a non-porous surface that you mentioned. There was a contractor that said, "Yeah, we just skim it, or we scratch coat it, and then go. We don't do a
Yeah,
porosity test." Well, the comment here is, whenever you add a layer of something like that, always do a bond test.
always. And in fact, if you read 3311, the bond test is do your full installation. So it can be a primer, underlayment, glue,
Act copy.
floor. Then you bond test that system.
Exactly. Yeah.
So good point for the person that said that, but absolutely, um, that is actually a true bond test. You don't do your bond test on the bare naked concrete, then prep and install on top of a skim material. Well, because that's not what you did your bond test on.
Yeah. Correct.
So again, people forget that you bond test, it's a mock-up of your full installation.
Yeah. Bond test the system.
Correct. Yes, sir. Yep.
Any other questions out there?
A lot of information, I know. But thank you all for hanging out. Last comments, there's my contact info if you want to take a screenshot or if you want to ask Chris or Lee to get my contact, I don't mind being contacted. I'm going to send you the slide deck right now. So they're going to have it in FCA. If you want any of the references I mentioned, please reach out. And lastly, if you need the AIA credit, please let me know directly and I'll issue a certificate. If you have an AIA number, we do self-report and I can make sure it gets supported to AIA.
Very good. Dean, with no further questions coming in, we should let you off the hook. And thank you very much for your busy guy. We appreciate you sharing your knowledge. We'll have you back. Don't worry about
Hey,
that.
sure thing, Chris. It's a pleasure. Like I said, we're working on that FFFL for you too.
Yes,
So
let's talk about that. If anything comes up, call me. I love that stuff. So yeah.
we'll do.
Good. Take care. And folks on the call, take care of yourselves. We'll see you next month and you'll get this recording emailed to you in due course. Yeah, thanks for attending. See you on the next one.